And we're back. 7.2.1 slope field. So we gave you dy dt equals t minus 2. So we're saying the derivative of y with respect to t. So the first thing we have to decide is this going to be an autonomous function or a non-autonomous function. Autonomous means that the function is not reliant on t. If you're autonomous, then you don't rely on anything else. You are your own person. Versus if you're non-autonomous, then you rely on something else. So I would say that this is going to be a non-autonomous function because you are relying on t to give you the function. If this were a y or if this were whatever else, then it would be an autonomous function. So what we can do is remember dy dt is going to give us the slope of the tangent line. Say it again. Dy dt is the slope of the tangent line. So you have to think of, you have the t-axis, it's going to run horizontally, and then the y-axis is going to run up and down. So we can find the slope of the tangent line at any point by plugging in t. And normally we'd have to plug in a y, but this one we don't have a y. So if t equals 0, then dy dt equals 0 minus 2, or negative 2. This is true regardless of the value of y. So y can be any number that it wants to be, but as long as your t is 0, that means that you're going to have a slope of a tangent line of negative 2. I said the 4-letter word. So here we go. We got our t-axis. We have our y-axis. The slope, and notice we made little local linearizations here. We said, okay, the slope when t is 0, the slope is going to be negative 2. So we made little tiny dashes. And if we wanted to, we could put a little tiny dash here and a little tiny dash here. Now notice these are sloping down pretty dramatically because they're approximately negative 2. So down 2 over 1, draw it in. Down 2 over 1, draw it in. And it doesn't matter what the t is, or sorry, it doesn't matter what the y is. If t is 0, the slope of the tangent line will always be negative 2. And you guessed it, what if t is 1? Well, then dy dt, the slope of the tangent line when t equals 1 is going to be equal to negative 1. This is regardless wherever you go on the y. So y can be any number it wants to be. I'm having trouble with this picture. Move it up there. So you'll notice at 1, the slope is starting to level out, down 1 over 1. And again, these are little local linearizations. What if t equals, you guessed it, 2? Well, then the slope of the tangent line is going to be 0. What if t equals 3? Well, then the slope of the tangent line is going to be 3 minus 2, 1. So then you can start to fill these in. And you can kind of see that these are going to create these little local linearizations. If you do connect the dots, they're going to create your function for you, which is pretty cool. So if we throw in 1.5 comma 2.5, we get this little guy. If we did 2 comma 0, we get this little guy. So you can plug in any t and any y that you want to, and you'll be able to find the local linearization at that point because, again, I gave you the derivative. So watch this. This is called a slope field for the differential equation. And what we can do is we can give you a point, and that point anchors your function. So if I said, hey, y of 0 is equal to 1. So when t is 0, y is 1. That's going to give you this slope field. And then what you can do is you can kind of connect the dots. It's not going to like go from here to over here to down here. It's going to kind of follow. You can kind of see what the curve is going to look like. It's going to keep going, and then it's going to bend back up, and then finally it's going to bend up here. So these slope fields are like all the pre-curves. They're what could be depending on what your anchor point is. They're the curves that could be. It's like your future. This is your future that can be. Which college are you going to go to? Whatever college you pick is going to put you on that trajectory. It's probably not true. You can probably pick any college and you'll be on the same trajectory. Who knows? I'm going to keep it under 5 minutes, 4 minutes, 33, 34. Like and subscribe. Peace out.